So now we're going to talk about some of the public health um, and really policy interventions related to nutritional status. And so looking at the chart on the screen, we've really come full circle. So, a long time ago, we recognized the importance of food and nutrition as it relates to health. And then we recognized deficiency diseases. And remember, we understood that these were diseases related to some kind of deficiency status way before we could actually identify the nutrient that was involved. And also, a lot of the times we recognized how to treat it and how to cure these deficiency diseases before we even understood the chemical structure of the nutrient that was missing. But then we discovered the nutrients and we discovered the chemical structures. And that was like early 1900s, right? We discovered vitamins. And it was at the same time that we were also, creating antibiotics and really focused on infectious disease. And so then we really had this emphasis on medication and how to supplement things with pills. But also what came out of this was like this fortification, and that actually has been really successful. So this is different than when we talked about antioxidants. When we talked about antioxidants, remember, those are important, but taking the pill form doesn't do the same thing as the food form. So there's still something we don't quite understand about it, but it's not as simple as just adding the exact component that is missing in someone's diet. You really need to have like a really balanced diet to get those antioxidants. With vitamins and minerals, it's a little bit different. So you can supplement, you can take the pill form, you can do fortification, which means adding it to the food. And so that was actually really powerful in terms of, improving the country's nutritional status. But then we got really focused on those little things, right? And then we got even more focused on like the other stuff because we were so zoomed in at the time. And then we are kind of now taking steps back and looking at how the environment interacts with our nutritional status, how the environment interacts with these little microscopic components and chemicals. And now we're kind of back to food as medicine. So full circle. So fortification is the process of adding nutrients or non-nutrient bioactive components to edible products. In the beginning, this was really to eliminate some of the deficiency diseases that we were seeing in the country. But now it's really to improve dietary intake. So let's look at a few examples. So in the United States, we add fluoride to the water, and that has really helped in terms of preventing dental caries or cavities and preventing, other dental diseases. And that might not seem very, I don't know, high yield in terms of like interventions, but the thing with dental disease is if you're in a lot of pain, one, you don't deserve to be in a lot of pain, but you also don't have a great intake of other nutrients, right? Because you don't eat as you eat like soft things or things that don't hurt, that don't necessarily give you a lot of nutritional value. There's also like missed days from work. So there's economic, issues. For kids, there's like, they can't concentrate if they're in pain. And there's also a social aspect. So actually like putting fluoride in the water has been a really good, public health benefit. There are still places where it's not in the water though. And then iodine deficiency, that's still a serious problem around the world. And here it was too. And so we added iodine and salt. And this fortification plan was actually, and I think still is, voluntary. And so it's interesting because now that you see like kind of these like foodie salts, like pink Himalayan salt and all these other like fancy salts, none of those are fortified. It's really just that basic table salt. So, there's something for just like sticking with the basics, right? Vitamin A deficiency. This is the leading cause of preventable blindness in children. It can manifest as a milder form of night blindness and progress to permanent blindness in stronger cases. It also increases the rates of other serious illnesses. And so this is where, eating vitamin A, eating your carrots can really help. Now, it's not going to give you like superpowers. You're not going to have x-ray vision or anything. But if you are susceptible to this night blindness, or it can help with some of that. I'll let you watch the thyroid physiology on your own. Thyroid hormone does a whole lot in your body. And so the important thing to take away from this is that if you like thyroid hormone synthesis really requires iodine. And this is, what we were talking about with salt in terms of fortification. So like table salt is fortified. If you have a deficiency, then you're going to have issues with anything that your thyroid hormone affects, which is a lot. You're also going to have issues with brain myelination. So this again will probably have an impact no matter how old you are, but it's going to be way more significant if you have this deficiency when you're younger. One of the diseases or the terminology that describes the disease of iodine deficiency was goiter. We still use that term today. And in the northern half of the country, it was pretty endemic at one point. So prior to the 1920s. And this was really because of different like soil quantities and like the geographic distribution of different nutrients. One of the things that brought this to the public's attention, because this was so endemic, one of the reasons why we actually figured out an intervention was because of the war. Because during the draft for World War I, a Michigan physician observed that about a third of registrants had an enlarged thyroid, and that disqualified them from the military. So we can't have that, right? We need lots of people to be able to sign up. And since a third were disqualified, there were big studies that were funded, and we figured out a way to fortify salt and fix the issue. So in 1924, we added iodine to salt. Among children in Michigan, the incidence of goiter decreased from about a third of the kids to only, less than 3%. That is a huge impact. And the estimated annual cost of the supplementation is about 4 cents per person. So, this is really a cost-effective intervention. And it's not something that you had to change the culture. It's not something that you had to educate people about, because you just supplemented or fortified what they already used. Dental caries are the most frequent chronic disease in the US. I'll let you read or watch the video by yourself. And fluoride helps. And so in the 1940s is when we started putting it in our water supply. By 2016, about 3/4 of the US had fluoride in their water. And the return on investment ranges from $4 in small communities to $27 in large communities. And that means for every dollar we spend, we get $27 back. And so big, successful intervention. Folic acid or folate, which is vitamin B9. So this is something that also does a lot in the body, and really any of these vitamins and minerals, because they are these cofactors and coenzymes, play a role in so many different chemical processes in the body. So um, this one in particular is a methyl donor in numerous reactions, and so um, a couple key reactions is cell division. So you need folate or folic acid to be able to give these methyl groups to synthesize and repair DNA and RNA. Very important. So epigenetics, remember one of the ways that one of the epigenetic processes is through methylation of the DNA. This is where you get that methyl group. And then cell metabolism, it also plays a role in a lot of these chemical reactions. So folate and folic acid, play a huge role. And so if you're deficient, and this is a deficiency that can happen at any time, but say you're an adult and you become deficient in this, you can present with anemia and a bunch of other symptoms. If you are a fetus who is deficient, you will present with neural tube defects. So let's look at what those look like. So neural tube defects, this is a broad term. Some very specific forms of neural tube defects include spina bifida and anencephaly. But basically, this is an abnormal formation of the brain and spine early in pregnancy. And so the way that your spine and your brain develop, we'll go with spine for right now. It begins as like a flat row of cells, and then it curls up and closes up. And all the other cells come around it and close up. And so if you're not able to do that, this is what happens. And so they actually tried to identify genetic causes for these in the 1960s. But because of the patternality, the geographic and social and seasonal patterns, it really pointed towards an environmental etiology. And so in 1995, so not too long ago, we started fortifying wheat grain products. And so post-fortification, neural tube defects decreased by half, which is great. So fortification prevents about 1,300 neural tube defects in the US each year. You can see a pretty dramatic drop. So in the beginning, it was voluntary, and then once it was mandatory, then it went down a whole lot. So let's go back. The thing is that there's still some inequities in terms of racial distribution of neural tube defects. And so it turns out that even though we fortified wheat grain products, and that led to a massive decrease in neural tube defects, there's still a big incidence in Hispanic population. And so take a couple minutes, press pause if you need to, but think about why that could be. So, someone might say who doesn't know how genetics works and, wants to like find some kind of biological reason, for different races and different ethnicities to have these differences, might point to, oh, well, there might be a genetic deficiency that all people who speak Spanish share, and that's why they're more at risk. And that is completely false, right? So let's think of another reason. One of the reasons that has been pointed out is that just they use corn flour more than wheat flour. And so since we only fortified wheat flour, we forgot the products that, is used by more of the Hispanic population. And that explains the lack of the decrease in rates. And so now I think that there has been a push to voluntarily fortify corn flour products, if I'm not mistaken. So vitamin D plays a role in a lot of different mechanisms in the body, but it's especially important for bone health. It also helps with immune function and it influences cell growth and development. Vitamin D is something that we're all probably deficient in because we really primarily get this from the sun, although some foods are now fortified with this. Vitamin D deficiency is rickets. And so this actually popped up around the Industrial Revolution when there was so much pollution in the air, especially in the UK, that it just blocked out the sun. And so even though, this is one of those deficiency disorders that we can still blame on so many different things, right? If we are talking about like what was the cause of rickets at that point, well, vitamin D deficiency. Okay, yes, at the very molecular level, it was vitamin D deficiency. But why did they have vitamin D deficiency? Because they weren't able to get much sunlight or sun exposure. Why weren't they able to get much sun exposure? Well, because of all the pollution in the air was blocking out the sun. And why did that happen? Because of the rise of industry and lack of regulations. And so then you can look at policy decisions, you can look at other man-made causes, and it's no longer as simple as just saying that it's just one molecule or one element that is missing. So it also affects the way that you intervene, right? So if we're just looking at the nutrient and we're looking at the deficiency, then okay, well, we'll replace that. Luckily for this, it works. Luckily, you can just fortify it and get some replacement. But that means we also didn't take care of the bigger issue, the root cause of the problem. Iron. This helps you make red blood cells. It's also important in a lot of different things in your body, especially immune function and antioxidants. We started fortifying flour in 1940. And iron deficiency, especially during childhood, can really lead to some learning and behavioral problems later on. So this is something that we still screen everyone for because we still see it a lot. So this disease has a lot of different names because it was described by a lot of different people in various places. But, there's a whole host of symptoms that are responsible for it. It often, there's a nice, interesting history that is in the notes that I will let you read by yourself. But this disease is due to thiamine deficiency. And so you see this a lot still in people who have alcohol use disorders, but they saw it initially, well, in a lot of different places, but also in Japan when they started milling rice a different way by taking away some of the nutritional qualities. So a lot of these deficiencies, as soon as we were able to identify the specific nutrient that was missing, it kind of shifted our focus to a nutritionism versus food. But again, that's really, it provides an incomplete picture because we have to step back and see why we were deficient in all of these different scenarios. And so again, we're circling all the way back to food as medicine and taking a step away from just focusing on the smallest molecule.